Alrighty, so the answer to that question is basically that since when you're at high latitudes, again, think like Antarctica, the air temperature is actually even colder than the water. The air is super duper duper cold. So that means the surface is like not any warmer than the deep ocean because the air is actually even colder than the water. So the surface of the water is about as cold as it can get. And it's the same coldness as the deep water. So that's why temperature is kind of the same at the surface and the same at depth because both are just very cold. So that's why at high latitudes near the poles, you tend to not have a thermocline. Instead, you just kind of have a line going straight down. All right. So next, let's talk density. So I mentioned density when I talked about ice and water. Density is a measure of how closely packed molecules are together. So if molecules are very close together, that's high density. If they're more spread out, that's low density. Uh, More specifically, density is a measure of mass per volume. So for example, if you imagine yourself holding two like cubes, like just little like, like that big cubes. One cube is made of styrofoam and one cube is made of lead. They're the same size, right? The same volume. The lead one, though, is going to be way heavier, right? The lead one's very heavy, the styrofoam's very light. So same volume, but this one has a much higher mass per that volume. So the lead has a much higher density than the styrofoam. Hi. So if we're talking about water density, there are two main things that will change water's density. First is temperature. Sorry, my cat is being a little gremlin. Look at her. She's a little gremlin. So temperature. Temperature in general, the colder something is, the higher the density. And that's also true of liquid water. Cold liquid water has a higher density than warm liquid water. So colder, higher density. And the other is salinity. If the salinity is higher, then also the density will be higher. So higher salinity, higher density. And both these things will change the density of the water. So for example, here, this is kind of a cool little graph that shows so the salinities on the x-axis and temperatures on the y-axis. And each of these lines represent a density. So you can see, so it would be the same density all along these lines. So for example, let's look at this line right here. This is 1.025. You can see that water that is around 32 parts per thousand and around, was that like 7 degrees Celsius will have a density of 1.025. Or if we're increasing temperature and increasing salinity, you can see that water that has a salinity of 36 parts per thousand and about, what is that, about 20 degrees Celsius will also have a density of 1.025. Or for example, so if we have this, low salinity and high temperature, the density is 1.021. If we have low temperature, high salinity, the density is 1.029. So again, if it's higher salinity, lower temperature, it's higher density. So next, let's look at temperature and depth. This is just showing the difference in the thermocline with different seasons. So just like, near the equator, you have a stronger thermocline, and near the poles, you have a weaker thermocline. You actually see the same thing, not only with talking about different locations, but talking about different times of year. So for example, in the Northern Hemisphere, when you're in August, the air's much warmer, right? And so you have this big thermocline. Whereas when it's colder, you have a much less of a thermocline. And when you have a really big difference between temperature at the surface and temperature at depth, you're also going to have a big difference in density, right? Because again, warmer water, lower density, deeper water, higher density. And I should also mention lower density stuff tends to float on top of higher density stuff. So if you've got very, very warm water at the surface and very, very cold water at depth, that means that you also have a really big difference in density. The water at the surface is much lower density. The water at depth is much higher density. And when you have really big differences in density like that, the water tends to not want to mix. It just forms these two layers and they kind of don't mix. They just stay where they are. We call that stratification, when water is forming these distinct layers that are kind of separate from each other. And usually this happens because of a difference in density. And whether the water is what we call well mixed or whether it is stratified, again, you have layers that are not mixing together, that has a big effect on the other properties of the water, things like nutrients, gases, that can affect living things. So, for example, let's imagine some clams living at the bottom of a small bay. And you can see in the autumn, the water's very well mixed. Whereas in the summer, again, because you've got that really big difference in temperature, you have very stratified water where you have this water not being very well mixed. Would you expect oxygen levels to be higher at the bottom of the bay? Remember, these clams are living at the very, very bottom of this bay. Would you expect the oxygen levels to be higher at a bottom that is well mixed, or during the season where it's highly stratified? So go ahead and answer that question below.